Thanks, Phil. Thanks for the introduction. Hi, everyone. Welcome to this workshop about shinyValidator. That's a very exciting workshop, something I've been developing in Novartis for more than 1 year. It's been testing internally on several production applications. And today I wanted to share how it works and how you may benefit from that work in your projects. So I'll have some slides on the left side, and on the right side of my screen, there will be some demonstration, some code demonstration. I'll move this thing here also. We'll have some breaks. So the workshop is basically organized around 4 parts, and we'll have some breaks in between, and also some practice. But I'll explain in a few minutes. So yeah, I'm David Granjon. I'm working at Novartis as senior software developer since 3 years. And I did a lot of things during those 3 years, and particularly starting at the end of last year, I started to work a lot on CI/CD stuff for Shiny, on how we may qualify, validate an application using CI/CD pipelines. This is a workshop, so yeah, you can take a coffee, make yourself comfortable. Don't be afraid to ask questions. I prefer to have something more interactive, even though we don't finish everything. I think the most important is you get the take-home message rather than like trying to absolutely do everything. So I'll start with a brief introduction, 10 minutes, just to explain what is the problem and where we want to go. And then I provide I'll show you how to set up shinyValidator, which should last about 20 minutes. Then we'll discover how we can use shinyValidator once it's set up. And the last part is to customize shinyValidator. I don't know if we'll have time to do the CI/CD part, which actually is not very complex. That's something you can do later on your own. And yeah, as I said, in between, there could be question and answers. So the slides are available here. You'll see, I'll give you a link also, because there is some platform you can use for the workshop, and you also get access to the slides. So yeah, you can get the slides here. I will paste it in the chat. Yeah, it's here. You get exactly same slides. These are quarto slides, and typically, yeah, you can basically, if you click on O on your keyboard, then you can have a look of what you can expect from those slides. You get an overview, you can browse through all different parts. So they're organized in different parts. And then for each part, then you navigate vertically. If you want to test it on your site, then you can clone the following GitHub repository. And then from that repository, you can work. And you'll have to work with RENV, do some RENV restore just to restore package versions. I set up all package you need so that you don't need to worry about compatibility on everything. And the important thing for today is this link here, which is the RStudio training tool, which is nicely provided by RStudio. And yeah, from this tool, if you go on RTT, then you'll go, you'll see this page here. Then you have to provide the identifier. So the identifier, from what was given to me is Granjon, which is my family name. And then you'll have to click on submit to fill your real name, to fill an email address, and then to click on enter. And after you'll get this, which is you'll be able to enter RStudio Workbench. So you have three choices. Yeah, exactly here. You have Workbench, RStudio Connect, Package Manager. You have to select Workbench. And if you click on Workbench, then you'll be pointed to that specific place. Here you have the class repository, which contains everything we need to work today. So you'll just have to click on that project, to select RStudio, to click on Start Project. And then the project should auto start, and then it will open on RStudio Workbench. You don't need to do anything like do RAM restore because it was done before during the preparation. Okay. So if you want to run it locally, like on your own computer, there are a few things you must know. We'll be doing some load tests. So you'll need shinyCanon, which is required to do load testing. It's a system dependency. You can install it from here, from the slides. It was already installed in the RStudio Workbench instance I showed, so don't need to worry about that. But if you want to do it locally, just keep that in mind. Same thing, you need a Chrome browser installed on either locally, if you are working on a server in your server. So it could be Chromium, could be Google Chrome, whatever. And finally, yeah, you obviously need Git, and if possible, a quite recent R version like R 4.1.0 should do the trick. Okay, so in the Workbench we have R 4.1.0. Locally, I'm using R 4.2 at the moment. I could change, but yeah, I'm using the most recent. Yeah, and the last thing, the workshop is recorded. It means if it doesn't work for you, you have some technical issues, then I would suggest just follow the workshop, listen to the presentation, just to stay on track on what I'm presenting. And then later, when a recording is available, you can take the slides, you can take the recording, and you can redo the workshop on your own. Okay, so I'm gonna move to the first part and just quickly check if there are any questions. So yeah, if you have any problem at the beginning, just let me know before we start. Okay, so I'm going to start the presentation. This is the setup, how you, so let me give you some introduction before the setup. So yeah, you may have a lot of applications, very nice applications, but if this application doesn't start, doesn't run, or if it crashes after some time, this application is not useful. So how do you transition from prototype to production? So first of all, your application must be reliable. Is the application doing what it is supposed to do? If you have a clinical application, which is showing tables, patients with adverse events, if for some reason table is not shown anymore, then the application is not useful for people, and that might be a problem. Is the application stable? Then the application do what it's supposed to do, but yeah, sometimes for whatever reason it may crash, right? You click on specific button and then there is nothing anymore. So it's very important the application doesn't crash just to be qualified as production ready. And then is the application available? You can have an application that does the job, that doesn't crash, but it can be extremely slow. And imagine if this application has to be used by a lot of different users, then if only one user can use it at a time, then it's a big problem because it's a poor experience for all other users. and then there is a lot of frustration. So you maybe agree with me that, yeah, in practice, very few applications meet these requirements. So what do we have now to make sure we can go to production? First of all, tools to structure your project, structure your application. I'm thinking about Golem here, which is quite popular now. Yeah, it was not like the case at the very beginning of Shiny, but now I think it's quite a standard. It provides package structure, helpers to get started, to create modules, to develop your application with best practices, and so on. So that's in the end, that's just easier. You get the package structure with documentation next to your code. You get also testing, can do many things, and it's just better organized, easier to maintain for you and for other people you work with. For dependency management, yeah, you have your application, it's well structured, but it doesn't mean it will work all the time, right? So if yesterday you worked with R 4.0 and tomorrow you go for R 4.2, and for any reason there are some breaking changes, package versions that are different, and then your application doesn't work anymore, and that's a huge problem. And that's not something you can really allow in production. The reason why here I show you RF, which is a package to manage your R dependencies. So basically RF will analyze the dependencies of your project and will create a log file which contains all package versions needed. And from that log file, you can share it with your team. You can basically update also this log file each time you want to include a new package or you want to change a version. And in the end, it's just easier because you know at some point you get a snapshot of the dependencies and you are sure your application will work. So it just increases reproducibility. On the testing side, yeah, there are many tools to test applications. You can just use unit tests to test the business logic because you don't have to forget your application is doing there is some logic behind. Not everything is reactive, and then you test like the basic pieces, if they work correctly. You get some server testing just to test how Shiny modules or pieces work together, in which you test reactivity. So this was introduced in, I think, Shiny 1.5, if I'm not wrong. Not available at the beginning, but I think it was okay. Like 2 years ago, it was already available. So that's a tool to test the server part. And you can also do some UI testing, just to test UI components, take some snapshot of the application, see if between different commits, then you get a different snapshot. You can do some headless testing with Shiny Test 2. And you get also many different other tests, like not shown here, but you could use also CPress and yeah, many different things. And finally, just to optimize your application, because if you remember, if your application is stable, if you can reload it, doesn't mean it's fast. So well, the question is, are there bottlenecks in my app? So you have multiple strategies. You could do load testing to test if your app can sustain simultaneous connections with Shiny load test, for instance. And then in parallel, you can also do some profiling using the provis package and see whether you have some bottleneck in your application. It doesn't tell you how to optimize your app, but it tells you if this specific piece of code is slow. And then it's much easier in the end to get it fixed and prioritize. So if you say in your app you have something that takes 10 seconds and you have another thing which takes 1 second, you know what is a priority fix, what takes 10 seconds instead of what takes 1 second. So that's what provis is really helpful. And also you can inspect reactivity with React log just to test for like any reactivity problems that can occur in your application. So in the end, it's nice to have all those tools, but it's better to automate. That's why we can introduce CI/CD, standing for continuous integration and continuous deployment. So continuous integration, you automatically check new features, you check if it's breaking your code, your previous code. And continuous deployment, you automatically deploy content, you deploy documentation or whatever you want. And it runs on a remote environment. It could be GitHub Actions, could be Jenkins, could be GitLab, and so on. The point is, yeah, there are a lot of different tools. I mentioned Golem for package, RM, testbed, React shiny load test, CI/CD. If you are not familiar with those tools and you don't know how to use them properly, it's just a bit complex, right? So the question is there a way to automate all of this? Because yeah, I don't have time to set up all these things. And this is where I will introduce shinyValidator, which integrates all the previous mentioned tools into one solution. And in the end, produces a single HTML report that you can share with quality in your organization, or you can share also with your colleagues. And then it's easier to have a centralized view of, what is your application state for this specific commit. And yeah. Okay. I'm going to move to the next part, which is how to set up shinyValidator. So the first thing, we will start to create a Golem project. As you see on the right side, I'm going to create that project. So you just need to call 2 lines of code, specify the location where you want to create the project, and then golate create project in that location. And then you wait the R session to restart. And you have a very simple Golem project, boilerplate project with like the package structure, the app server, the UI, the run function. And yeah, that's everything we need at the moment to get started. Obviously, yeah, here in the slides, I wrote package, you replace package and folder by whatever you want. This is not something you are supposed to do in this environment, because this project is already set up. So you can just follow basically my slides here. You don't need to, you can test it locally if you want to follow, but that's not an obligation. I just don't want you to focus on creating a Golem package. Here it's more about how to set up shinyValidator. Okay, then we need to create, to add some license, also to initialize the test, to use Git. So I'm gonna use this, which contains many useful functions to add files to your package. Okay. What's different now, I have a test folder, which will contain the unit test. At the moment, I just have a dummy test file, which is not very helpful, but we'll add new tests later. We have a license. We have version control also. You see, we have a Git tab here. We don't have GitHub repository at the moment. We'll take care of that in few minutes. And what is important now is to put some real server code. So this is something here you'll have to do on the project, on the plug and play project. You can do it now if you want. So you need to replace the server part by this code here. All right. I'm going to do it also on the local project. And same thing for the UI app.ui.r. I will copy this piece of code, which is very simple. It's just a slider input with a plot output. And I draw a histogram here. That's very, very simple, but that's basically a bit more complex than what Golem just provides by default. Because if you look at the Golem boilerplate, you just get a simple title here, which is not very helpful. Okay, so now I just replace the UI part. I do the same thing for my local project. And then I have to go to GitHub just to create a remote repository. So here I made the assumption we are going to use GitHub and we'll use GitHub Actions. This is also working on GitLab. It's just from a statistics point of view, there are more people using GitHub in organization than GitLab. At Novartis, we use GitLab, but that's not the case everywhere. Okay, so let's go to GitHub. Going to create a project here in my organization. So I will call it validator. That's the same name I gave in my local project. Okay, I can make it public. I will click on create repository. Okay, and now this is important. I get some command line just to explain me how I can add the remote on the local repository and so on. So this is what you need to copy. I have an existing repository here, and I'm going just to add the remote. Okay. If you want to check whether you have a remote, obviously you do this here, and you'll get nothing. Okay. So now I have my branch main. I have my remote. If I rerun the command I just ran before, you'll see I point to the GitHub repository, which is great. And the next step is to set up RF. As I told you, this is really for reproducibility, making sure even if you upgrade a package in another project, you won't impact this project. So we start by creating our environment file. So this is what this command is doing. And inside the environment, I'm pointing to a specific location for the very specific environment variable, which is library root. And what it says, it will tell Renv not to install the package inside the project, but to install them outside. That's important because if you install everything inside the project, then it may be, you may have some lags when you do checking, when you do a DevTools check, it may trigger some lag. So that's what I always do by default in all my projects. And then, once we are okay, just checking options, repo. So we are here. We can call rm init. I'm going to restart R, so that's important because I created our profile and just to, our environment, and I need to restart R so that this environment is considered. All right, I'm calling rm init. And I obviously need to install RM. Okay. So it needs some time to discover the package dependencies. And then it will download all required dependencies from different locations. And just install them in the project. If you never did that before, it will probably take some time. In my case, I already made it multiple times. So it's pointing to a centralized cache so that, it's taking less time for each project. So we'll give it some time for the installation here. And then in the end, you'll see this message. You'll see that the project is loaded with a specific RM version, like you see on the RStudio training tool. If I restart the session, then I get the RM, which is correctly loaded. So you see here, it was quite fast because everything was taken from the cache. So you don't need to wait for 2 hours to get everything working. If you need to install any other package with RM, obviously you can do RM install, you specify the package name, and then if you modify, you want to capture a new dependency, you do RM snapshot, which will update the RAM log file. So this is what the RAM log file looks like. This is a JSON file, and then containing the R version you're using, the repositories you're using, and the package versions you need for your project. So if someone else in your team is taking that project later, when he's working on that, he will first have to restart the project. Okay, so we have RF. Now we need to install, obviously, shinyValidator because it's not there in the project. So I'll do devtools install _ GitHub Novartis / shinyValidator. Obviously, you can see shinyValidator is not on cron yet, but it will be because there is the coverage is about 80%, and it's just about submitting it to cron and answer reviewers if there is any problem during submission, then just fix those issues. So we install validator. When we are okay with validator, we call the function use _ validator. So that's very similar to use this. I chosen something very similar. This is on purpose. And we select GitHub. You have different flavors. There is GitLab, there is GitHub. You also have GitLab with Docker executor and many other things. I won't enter into details today, but we are going to use GitHub Actions. I do library shinyValidator. It will help. All right. Then it's a good practice to restart the session. We'll have to do a RAM snapshot because what shinyValidator is doing, it's adding some package in the suggest and stuff like that. So you need to capture in the RAM block. It also creates some files. In the inst folder, you have some JavaScript files which are required for some testing. I will explain later. And you get a new function here in the R folder, which is called run app audit. So this is what will be run during the validation. So it's a modified run app function just to make sure everything works properly. And then you also get a .github folder for the workflow, especially the validator workflow. So this is a file in theory, you don't need to touch it, except if you want to modify the validation. And we'll check that in the last part of the workshop. But you get everything to install, to restore RM, to select like the machine you are going to run on, to set up dependencies, shinyCanon, Chrome, to lint the code, to run the audit, to deploy the report to GitHub page. So that's everything set up, so that you really don't need to worry about that. So in the spirit, that's very similar to Golem, very similar to USVIS. It's just creating some files in your project so that you don't have to worry about creating them yourself. Okay, so I'm going to call RM snapshot. And here, yeah, this is what it's going to do, just to include all those packages in the RAM block. Okay. And I will push everything to GitHub. Just one thing to make sure, just if I have lubricate. No, I don't. So I need to do in rev install lubricate dt r markdown, and I think the last one is vdifr. Okay. It's just to make sure this package will be available on CI/CD. I do RM snapshot again. And in the meantime, you can see how it works with RM. So you see, I have my new packages here that will be added in the RAM block. Okay, and I can commit. So I will create a very simple stuff. First commit, click on push, and that sends my code to GitHub. Okay. So now if I refresh, I'll get the package with all the code inside. And what's important, I also have the actions, GitHub actions. They are running here. So I have my first GitHub action with everything needed. So I'll come back later on that, but as you see, yeah, it's just setting up everything, pendoc, R, system dependencies, restoring RM, and so on. So it's taking some time, and then I'm going to stop the installation. So this is everything you need to install shinyValidator in a new project. If it's an existing project, yeah, it will depend mostly if you are very close to a package structure like the one provided by Golem. It's not really a prerequisite to have Golem, but yeah, you still need to have the same structure to get a validator work. So I really advise you to use Golem. Okay. So I'm gonna move to this part, and then we'll do a break. We'll do a break at the end of that part. So we'll have this thing here, which explains how shinyValidator works. Then you have some practice, and here, if we have time, maybe some CI/CD. So how shinyValidator works, this is what's shown here in this diagram. You get your Shiny project, and this project may be a DMC application standing for Data Monitoring Committee app. And DMC applications, they have like strict expectations. You must have something which is very well tested, which works, doesn't have a lot of crash. And yeah, if you compare to a proof of concept, then obviously you have much more expectations. And in between, you may have a lot of different type of application, which could be more or less strict, depending on what they are doing. And yeah, shinyValidator is doing a series of tests. So here it's written CI/CD because the ultimate goal is really to automate this, right? So you don't have to run shinyValidator on your own each time you want to do it. That's done on the CI platform. But it can also run locally. And so today we are going to do both, to run it locally, to understand, and to do it on CI/CD. So if we come back to our expectations, if you take a DMC application, you may have, what you want to do is to check the quality, and you want to have also to check performances. So we start by linting the code. So we use linter, check for code formatting, the style, because I think the first thing to do in your code is making sure you have something clean, which is easy to read, and also for other people in the project. So if you have like bad style, bad indentation, you don't follow like you have lines with, I don't know, 1,000 characters, that could be a problem for long-term maintenance. Then we have some quality checks. So there is a RCMD check, which is run, some crash test, which basically checks if the application starts, then if it stays alive after some manipulation. So we'll play with the app in the background just to see if it's still alive. And then you get output checks to check if your application has outputs, then check if they are still the same between commits. So you may have different plots. And if you are doing one change in the code, it may break that specific plot. So that's something you can track with shinyValidator, and that's gathered in the quality part. And you have, on the other hand, the performance investigations, such as the profiling. Is my application fast? So you'll be able here to check if your code is slow and find why. And also doing some load tests, just to test if your app can support multiple users. If you take, on the other hand, the proof of concept app, then you have less tests. You are not necessarily obliged to do performance tests. So you can just do the lint part and the quality checks. Overall, just making sure the application starts, and that's it. So the framework is very stable, very flexible, sorry. You can really do only quality tests if you want performance and whatever test you wanna show. And in the end, an HTML report is created. Everything is centralized, and it's deployed on a server. So it could be deployed on RStudio Connect. It could be deployed on GitLab page, on GitHub page, or whatever private server you want. The main function is called audit app. So as I said, it works on CI/CD. That's the main purpose, but it can also work locally. And this function has main parameters. The main one is headless actions. So headless actions will contain instructions you want to pass to ShinyTest2. So I'm going to come back to this in few slides. Timeout is a time you need to wait for the application to start. If the application does something before starting, you need to wait, I don't know, 10 seconds. You can specify a timeout here. You have parameter. So here is in case you want to pass parameters to run app, like you would do, in a Golem app. You create specific parameters. If you want to log to a database, for instance, with environment variables, then you can pass it here in the obviously. And you have other parameters like scope. So at the moment you have 3 scopes. Manual, here you are free to set up any level of test you want. Then DMC, for DMC, you'll have everything. And then for proof of concept, you'll only have package check and the crash test. So by default, it's manual. Then you choose what you want to bring, like if you want to validate the plots, if you want to have the coverage, if you want to do load tests, if you want to profile the code, check reactivity, and everything. As I say, it's flexible. In that case, if we specify profile code equal false, we don't have the profiling here. We'll have check, crash test, load test, coverage, reactivity, but we don't have profile code. If we specify audit app scope proof of concept, you'll only get check and crash test. So the main thing about shinyValidator is it heavily relies on shinyTest2. Everything is built on top of shinyTest2. So you'll have to manipulate your application in the background. And here you specify some instructions. So for instance, if you remember, we have our application with a slider input. Here we want to set up the value of that slider to 30. And here we want to take a screenshot. There are many other things you can do with shinyTest2, but this is really using shinyTest2 API. So I really recommend you to visit the shinyTest2 website and have a look at all the functions you can use. Here, app, it's a like parameter referring to the application you're auditing, your application. So this code will be run during crash test. So this will be the protocol which is run during the crash test in that case. So that's not, in this example, that's not really powerful crash test, but that's a quite good start. And it will be also run during the profiling, during the reactivity check. Okay, so now it's time for a bit of practice. So you can go to the project here in the RStudio Workbench, open the project, and then you'll have to copy this code. So I hope you also have the slides on the side so that you can easily copy the code in RStudio Workbench. So I'm going to create a script. Okay, so let me just restart the session. I will create a new one here. Okay, so this is my project, going to create a script just to put the instructions from that activity. And the first thing we do here is calling shinyTest2. So we do library shinyTest2. And then we call the app driver. So this is basically starting the application in the background. And from a headless point of view, it means you don't see the application, but it's running in the background and you can manipulate this application. So if you inspect the object, this is the driver. And then with the driver, you have many different options. Yeah. Okay. So I'm going also to do it locally here. Just one thing I need to copy is the server code. Okay. And the UI part. So I'll start the driver also in this project. Oh, yeah, that's important. Also, I don't have something missing here. You see there is a app.r file. This is because locally I missed something. So I missed to add the Shiny app file. This one here. Yeah. So I call golem at underscore Shiny app CIO underscore file, which creates file actually, which will work also for RStudio Connect if you're using RStudio Connect. And yeah, I'm going to restart R. So we give it some time so that the driver starts. Okay. So I have my local driver. I also have the driver on RStudio Workbench. The reason why I created the local one and also the one from Workbench is this function here, this method, headless app view, won't work if you call it from Workbench. So if you try, you will get missing X server, blah, blah, blah. So that doesn't work from on the server. You have to run it locally. So if you run it locally, then it will basically open the headless app, right, which is running in the background as a debugging purpose. So here the main purpose of that is just you design your test, your headless test with that debugging tool. And once you're okay, you don't need to view the application anymore. So that's just for you to see if your test is doing something. So that's the reason why I'm showing this window here, because yeah, that doesn't work on RStudio Workbench. And now we are going to call headless app set inputs. And then I specify the name of the input, which is ops, and I specify the value, which is 1. If you have multiple inputs, you just specify them with a comma and then you enter them. And I click enter. And now here, I'm going to do it locally. I still get the window open and you see what it's doing. So you see the input value is on 500 at the moment. If I run that command, it will move to 1. So this is what Shiny Test 2 allows you to do, it really to manipulate your application in the background. That's extremely, extremely powerful because you can really do whatever you want. All right. So if you are running on Workbench, the only way you can know if this worked is to do this. to call get value, get underscore value, input equal ops, and then you get 1, which means, yeah, the input value is really 1. You can also, here, this is really getting one specific value, but you could get actually everything. You could get output, output values. You could get, yeah, here you get input, the plot input. And also some exported values. Yeah, we don't have any exported values, so that's nothing important. But basically, if you have some reactive you want to track, that's best practice to export them with shinyTest2, and then you can track them in that list. What's also powerful is you can run JavaScript code directly. So don't need to worry what this is doing, how this works, but that will just set the slider value to 100. And that's doing it with JavaScript code. That's not doing it with our code. So if I run this in the console, and then I do get value input ops, it will be 100, like the value I specified in the JavaScript. If I do the same on the local application, all right. You see, yeah, it's doing exactly the same thing. It's moving to 100. So that's really to show you can really run whatever you want, and that's really nice. And at the end, when you're okay with the test, yeah, you call headless app stop. This is not something you need to do with shinyValidator, because shinyValidator do it automatically. But here we are, yeah, we are not directly using shinyValidator. We are explaining how shinyTest2 works. So that's, you need to clean it manually. Okay, so I'm going to stop the RStudio Workbench application. Yeah, and yeah, I hope it's working for you on RStudio Workbench. Feel free to share in the chat if you get some issues in the project. Okay. Now I'm going to explain what happens if you don't have the custom manipulation I showed. So by default, shinyValidator runs a monkey test, which is like a blind test for your application. So it's really clicking everywhere, as I'm showing in this video. It clicks everywhere. It feels any kind of input, drag and drop. It will scroll in the app, click on tabs. And the goal of that is, in the end, you want the application to be alive. So that's, if you have an application with tons of inputs, outputs, it's sometimes nice to do that kind of monkey test, just as a crash test. If you have an application which just contains a slider input, like the one we have, that's not necessarily the best thing, because yeah, there are some chances it's not going to click in the right place, or not doing the right action. So let me show you what I mean. So that's a second activity here. Something you can do on your site. So what I ask here is to run the app.r script. So you'll have also to run it external, to select run external. Okay, so I'm going to run it from here. And you see the application, very simple, slider input on the plot. You will open the HTML inspector with a right click and then inspect. And then you'll see different tabs. So what's important here is to see the console, show the console tab. So it's possible that in some case you don't see the console, so you have to click on show console drawer. So yeah, it could be like in that state. So you just have to click on the 3 vertical dots, show console drawer, and then we are free to use the JavaScript console. And then we have to go here on the I paste a link in the chat. So that's a link where you have to browse. And from that link, you have to copy what you get here on the right side. Then you go back to the application, which is running here, and you paste the code in the console, in the JavaScript console. You click on enter, and you see it's running exactly the same as in the video I showed in my previous slide. So it's a monkey test. So yeah, that's not very interesting here because, as I say, there is one slider, and as you can see, it's doing everything except clicking on the slider. So it's not particularly helpful. That's the reason why, yeah, you have the possibility to specify to specify custom tests directly with the audit app function. So I agree, it's quite fun to see all these things moving, right? It's quite nice. But yeah, in this specific case, that's just not interesting. There is, I wrote an article on the shinyTest2 package. If you go here on the articles, you have something about monkey tests. And I explained that problem where it's not necessarily a good idea to do monkey tests with a very simple app like this. And then you get some code to make it more specific. So if you go at the end and you copy this code here, that will target the slider. So the monkey test will really be targeted to the slider. So if we try, you see now the slider is moving. Yeah, it's slightly moving, right? And then basically the test will stop in a few seconds. And if the application didn't crash, then you have good chances it's quite stable, right? So that's better than really the blind monkey test where you do sometimes you don't do things really meaningful. And then I'm going to move to what you get at the end of the shinyValidator run. So you get that kind of report. So that's obviously a bit better when it's deployed on a server. Here it's just iframed in the slides, so that doesn't render quite well. But what you get is the output of the package check. If it's a success for the building, if you can install the package, what is the status of the check, and what is the outcome of testing. So each time you get a step validated, then you get a green tick. If you get a warning, for instance, in the checking part, then you get a cross. Because yeah, in general, if you want to submit a package on cron or whatever, you can submit that package if you have warnings. Even if you have not, it's quite challenging. So there is no way you can submit with warnings. The reason why you'll get a red cross in that case. And same thing, if you get a failing test, you will get a cross. So here we don't have any tests. Obviously, you don't see anything. Here you get the crash test reports. So as I say, what's nice with Shiny Test 2, you can take screenshot of the application. So by default, there is one test, which is one screenshot taken when your application starts. And at least you see, in what state your application starts, if it's crashed or whatever. And then the second step is the headless gremlin test, the monkey test. That's the default one if you don't specify a custom test. And here you get a screenshot of the application at the end of the test. So that's important. And same thing, if the application is crashed, you could see a grayed out screen and so on. So it would indicate that there was something wrong in the application. Here you have output validation. So when I say validation, you must be careful. It's really more checking outputs if they are the same between the previous commits. And here what you see is a difference between the current commit and the previous one. And the difference is shown in red. So here you see it's very different, which probably means there is something wrong in the code. So here you have multiple views. You can have a slider with a new plot on the plot before. You can show the difference in red and so on. So many different things. If you have HTML widgets like eCharts for R, Plotly, whatever, then you won't see the plots. You would see a table containing the data, the widget data. Because for HTML widget, you pass data with JavaScript, and then it's handled with the corresponding API, eCharts or Plotly. And then, you are able to see the data changes, like on GitHub, where you would see the differences in red and green, just to see if you are if the plots are the same between different commits. Here you get the coverage report. So it shows mostly you have multiple scripts for your application and how much percentage is covered by the unit test. So here you see I don't have much coverage. I hardly have any unit tests, so that's quite expected. You have the load test report. So here it shows, we don't have time really to explain in all details what you get in the load test, but what you would like to see is everything in blue. The less blue as possible, because blue means computation, it means calculation. And gray means standby. So you would like to see a lot of gray and another lot of blue. And same thing for the red. The red is the home page, the time to wait before you get the application shown on the screen. So same thing, you don't want to see a lot of red. And in that case, for this specific app, that's not very good because you get quite some blue, which may lead to issues later. Here you get the React log graph. So that's showing the reactivity graph of the app. For this application here, I have two outputs, ggplot and another one, which is eCharts. And then, you see what are the dependencies in the graph, and based on that graph, obviously you can invalidate different parts and see how it works. And if there is any missing link between inputs and outputs, you can track them here, obviously. Here you get the profile report. So the profile report is basically on the performance side, like the load test. It tells you, for instance, how much time a specific part of your code takes. For instance, like the eCharts plot takes 30 milliseconds. For the ggplot, 70 milliseconds. So here it's quick. You don't have much problems. So yeah, any bottleneck, you would see it in that part. But yeah, don't worry about that. We will come back specifically on each part in the next activity. So before closing this part, I would like to give you 5 minutes to run this code here, to run shinyValidator audit_app with the proof of concept scope, which, if I remind you, will run a crash test and also a package check. So you can copy this code in RStudio Workbench and yeah, run it from here. So in the chat, I see, do we need shinyCanon setup to run this? We need shinyCanon if we run the load test. And in the RStudio Workbench, in the RTT, the RStudio training tool, shinyCanon is installed already, so you don't need to worry about that. If you work locally, then you will need to install shinyCanon. And if you go to shinyload test, the package description, then you'll get installing. In the installing article, you get some explanation how to install and run shinyCanon. Yeah, for your specific operating system. So this is where you would have to go and install. Okay, so the test is over. So you see I have some the DevTools check here. I got the crash test. Yeah, so now we have a new folder, which is called public. And in the public folder, I have my HTML report. So you click on view in web browser. And then it will show like the same thing I showed in the slides. So you'll get the package version, the commit code here, the package name, and then the results of the DevTools check. It's not super interesting at the moment because we don't have unit tests. But yeah, you get some some screenshots of the crash test. Same thing, we don't have custom crash tests, so it's not doing much things. It's not changing the slider, but yeah, we'll do that later. And there is an extra tab I didn't really mention in the presentation. That's the dependencies tab. So it's basically here, like for a later feature, because a later goal will be really to validate your package dependencies against any restricted environment. So if you work in a closed environment, you have strict package versions which are locked. And in that case, you would like to know if you are compliant with that system. And sometimes when you are developing your app, you may install some GitHub package that are not necessarily compliant with your organization. So that's the reason why you get this feature here. So in my case, I don't have any restrictions. So you see everything in gray. But if you apply some restrictions, then you would see in red everything which is not compliant, and in green everything which is compliant. So I see some quite some issues in the chat about like there is no shinyCanon installed, there is no package. So just make sure you are really in the class repo project, because if you're not working in the class repo project, then you won't get the RAM folder and the package. Another question, how long it takes to build a report for big applications? Yeah, if you take like a profiling, for instance, the more code you have in your app, the more time it will take, because you will really scan all files. It also depends how long you are like recording the test, the manipulation, if you're just moving one slider or if you are doing like 1 minute of test. That's really depending on the application complexity. Yeah, so yeah, in theory, shinyCanon is installed in RStudio Workbench for everyone. So you should see it in the system dependencies, but yeah, there might have been some problem for some sessions, unfortunately. So as I said, in that case, don't panic. Really, just listen to the workshop. Everything is recorded, and you'll be able to try yourself later. Okay, another tip I give before giving a quick break. So each time you audit the application, yeah, you see it creates a public folder here. So I would say it's good best practice when you're done with that public folder just to delete the folder. Also to click on session, restart R, just to make sure you restart clean before doing the next step. Okay. So I give a short break here, about 2-3 minutes. So if you wanna drink something, yeah, gonna try to answer some question in the meantime, and then we can restart. Yeah, in about 3 minutes. Okay. So yeah, I'm going to move to the last part for today. So here, that will mostly be you running the code. So just for the interest of learning, we are going to disable load testing, disable profiling, check reactivity, just really to do things one step at a time, and just doing the crash test first and so on. Because if you remember, everything is enabled by default if you don't specify the scope. So I go to Workbench. I will just paste this code here I got from the slides. So it's just easier if I put Workbench on the side for you, so that you can see the slides at the same time. Okay. And now we are going to add some server testing. So the goal of server testing is really to test reactivity in your app and how pieces work together. So when I say pieces, I say modules, for instance. So we call use this use test, and the thing is called app server test. And this creates like a very dummy test just for multiplication. And we are going to replace by the real server test. So how it works, you call the test server function, and then you point to app server, which is the main, the app server function here. But you could definitely test modules instead. So I'm not going to show it today, but this is possible. And in our case, that's not really meaningful because we are really testing the application from a global point of view in the shinyValidator. So that's not really like just one module. And here we manipulate the application. And that's important because the server test, it's run without the UI in mind. So you don't have the slider input. You need to set the input. So it's a bit the same you do on the with Shiny Test 2, you know, with the set underscore inputs. So here you play with session dollar under set inputs. You specify ops equals 0. Obviously, if you have ops equals 0, you expect an error in the plot. So this is something you can capture in the test with expect underscore error. And then you specify set inputs equal 100. And then you just print the output. And that's a way you have to test the fact that your output is here in your application is generated properly. So let me copy this instead of the placeholder test. I'm going to replace it. Important to make sure you have obviously this part in the server, the plot, the dist plot, and also the slider on the UI, otherwise the test won't work. All right, and if you want to test it locally, you can run DevTools test. And yeah, well, what you should see is basically a success, right? And then in the end, you get the structure of the plot. So you get base 42 code of the plot. So this is something which you can use to reconstruct the plot image. And then you get some other stuff, which are really the plot structure. But yeah, here you really test that the plot doesn't show when you get ops equals 0, and then it shows when you specify any other value. And then, yeah, as I said, don't forget to, because if you run shinyValidator before you have a public folder, don't forget to remove the public folder. This is not done automatically at the moment by shinyValidator, but maybe doing later, and then yeah, restart our. And I'm calling this shinyValidator audit app with load testing disabled, profiling disabled, and reactivity check disabled. And the first thing you see in the logs is the packet check. So you can, I let you run it in the same time. You can also have a look at what happens on my screen. So you see, I get some notes here, but he doesn't know where hist is coming from. Our norm also giving me some hints how to fix this. Then it does the crash test. I don't have any specific protocol here. If you remember, the headless actions parameter is new, so I don't have anything. So it's doing the monkey test, the default monkey test. And now it's doing the coverage report. So you see here. So you see, for instance, I have 100% coverage on the app server.r because I'm testing the plot and there is actually nothing else. So that was pretty straightforward. And then you click on view in web browser. Alternatively, as I said, you can deploy if you were here in the break, you can deploy the report in RCU Connect. Okay, and this is what you get: the check results, the crash test, the monkey test, the screenshot, dependencies, and the coverage. So the coverage shows here that, yeah, I'm testing the plot twice, actually, because I have two checks for the error check and also for the when I change the slider value. And yeah, I get also other files which are not covered, obviously, by the unit test. So that's here not really meaningful because I don't have modules, I don't have very complex application. But yeah, you have to understand that in the end, all your unit tests will appear here in the coverage report. Okay, so I'm gonna clean the report. I restart the session. And then the next step is to customize the crash test. So this is what I mentioned before. We have some screenshots taken, but they are not really meaningful because, yeah, you don't really target a specific input or whatever. So here, in that case, we will change the slider value to 1000. We'll take a screenshot. So that's mostly the same test, but except we have we are manipulating the application in a like meaningful way. And then I click, I run this function again. So at the end of the day, this is not something you are going to do all the time, right? What I'm doing locally, that's just for you to understand step by step. This thing here will be running on CI/CD, and the report will be uploaded to GitLab page, GitHub page, to RCU Connect, wherever you specify in the CI/CD instructions. But the goal is really to automate the testing and the report generation. So it doesn't do the unit test for you. You still need to write the unit test. There is no solution for that. You will always have to write the unit test, but yeah, you won't have to. You don't need to worry about doing a load test on one side, another one, a profile test on the other side, showing the load test report to a team, showing the profiling to another team, and so on. So you get everything centralized. In the logs, you see here, it's a bit different. The message I get, it says running custom headless crash test. It means I'm not running the monkey test. And yeah, here I get another report, which is almost the same as the one before. The only difference is the crash test. So I have the init screenshot, and then here this is the screenshot when I change the slider value. So you see here my application is still working. So there are good chances it will be stable in production. Again, obviously, do much more things, like as I showed in the previous part, you can inject custom JavaScript code. You can, yeah, do whatever you could do with shinyTest too. But yeah, just for this workshop, I think it's complex enough just to just change the slider. I think it's it's just okay. Now is to clean the report as usual. So that's a bit tedious now because yeah, you need to clean it. On CIC, you don't need to clean. This is done automatically. So now we need to do some output checks. So as a reminder, it compares what is the output between this commit. So you will get a difference in red. So what we do is we copy this function. We create helper.r script. Helpers. And inside we create a function which is called make_hist. Just create the histogram based on a specific value, and on the server that you place replaced by the call hist. Okay. And now we also turn on output validation. So you specify validation equal true. Then you run the audit again. Actually, step before some good. I just show you is the unit test for the plot to work if we proceed like this. Create a test which is called base plot. I'm just formatting my and insert. So you must check if you have VDIF installed. If it's not the case, then you can install with rm install. So in theory, it should be done, but yeah, one never know. Dummy here. So what VDIF is doing, it's just sure always get the same histogram. If you don't specify, then you have a failing test all the time. So that's important to fix it in the test. And then you call the VDIF_r expect_doppelganger. You will call and make hist with whatever value you want. Here I specified 500. And then you test. So that's you need 4.1.0 at least, because I checked multiple times. If I was using R4.0 or whatever, I got it didn't work. I couldn't get any snapshot. But when it's doing, it creates a snapshot of the base plot, SVG snapshot. And it does the same for plots. It will create one plot. So yeah, I have only one. Imagine multiple snaps. And then those snapshots, they will be compared at each commit and can preview the difference in using the VDIF_r package. So now if we have the snapshot, if we go to change the formula, we I don't know, we do a typo on Friday, we are tired, right? And then we change the value, and we didn't realize we did that. Then I do DevTools test again, and I'll get a failure, obviously, because the snapshots, they are compared. I have the new snapshot and I have the old one. And I can preview the differences by running test at snapshot review. A widget showing the differences. So from what I have in the slide, but yeah, you get the difference in red, and then you have other mode also, like the toggle mode, slide mode, and so on. So I prefer the difference because you really see what's different. Yeah, this is something you have to do locally. If it's something you did on purpose, you can act. If it's obviously something wrong, you need to fix what's wrong in the code. And then, yeah, then we can run shinyValidator function here. And your widget comparison widget will be included. Will be done for each plot you have in your. So if you have plot lattice or whatever, you'll get SVG. If you have HTML widgets like plotly, eChart4R, you don't get an image, you'll get a table instead with parentheses and green, like in div tab, like here. Yeah, this is what you get basically. Green, what. So crash test is over, good comparison is over. Now I have to go in the report. So you see I have a bit more an output here. Important, yeah, I get basically just showing the output validation. Okay, so this is mostly at the moment we checked the global quality of the application, the style with the lint, package, the file structure. We did a crash test, like a startup test and then a crash test. We checked whether the output also was correct. In that case, not. Then this is another problem, but you have to fix it later. We have average. Now we can have this performance side. We can write the application. Yeah, just have a look at the file, see and so on. So I can activate the profile. You just need this thing here, profile underscore code equal true. You rerun the code here, it will redo all the previous tests, output checks, and so on until the file. And in the meantime, I explain you what we are going to do, and also test on your site. We create a slow function. So this function takes in our programming book. So that's a very nice book if you want to improve the our code. And yeah, you have a slow function and very non-optimized function. We call it in the just before the make histogram, just to make something laggy. And yeah, here if specified this number, that's enough to make the application reasonably slow, not too slow. We don't have like 2 hours to wait. Yeah, so you see here the code profile is running. It was running the crash test during the profile. Now the report was generated. And yeah, to the coverage report, and I have yeah. So it's not really fast, but it's not slow for simple apps. As the more complex the application becomes, it will need more time to your report. What's different? Profile type. So there is a bug in profiles on split horizontally. So I click again to display on time. This is going to at some point. Here I show a flame graph. So you get on the left, you get your code split by files. The run we're not in that one. The app UI here you get the app server. So you'll be probably most interested in the app server. So if you have it also works. You get your module files listed on the left side. And on the right side, you get a flame graph. So you get the time on the axis and then the call stack on the y-axis. And you see here, for instance, how much time the plot was shown. So it was shown twice. The first time when you open the app and the second time when we change the slider. There is it's fast, and there is no reason why the application is laggy on production. Now, we copy this slow function in the helper. We paste this function or okay, so you change this value. Don't put it too high because it's not going to. It's going to take really long time. Yeah, and that's not really the goal of today. So just make it a bit slower. Okay. Again, but we start by section. The profile is and here is different. You'll need a bit of time out because to take some time to start. So it's here when it seconds, it could be 20 seconds. Have lags on the server, even in, so that's not really something to really to experiment. And then yeah, I'm going to disable output validation just for to make it fast. And then yeah, the in the it's not impossible. There are to CM just this because yeah, it takes that's probably that takes the most of time. But yeah, that's something that might come in the future. So if you have error message from Shiny Test 2 you see in the you can try to increase the timeout like for I don't know 5 seconds. We'll remove the public code and try again. I didn't get any errors, so that's quite a miracle. Usually, it rarely works all the time. Okay, I'm in the public folder. Report, the code file. As I said, yeah, you need to here doesn't. You see the app. It's really slow. It takes about 6 seconds to run that function. It was taking 10 milliseconds before. So you have a really my app is slow, and why it is slow because I have that function, and that function gives you some ideas where you would have to act and what's the reason why your application became slow. The commit number, you go back to what you changed in your application, and it's much more easier to maintain in the long run. But in the slides, there is a report just in case you want to see. And the last part is about load tests. Testing, just checking if your app can support multiple concurrent sessions. Yeah, it didn't work when I tried before. I don't think it's going to work now. Something basically turn on by doing load equal, and it's doing application with simultaneous users. So that's something you can specify with audit. So you parameter worker, much simultaneous sessions you want to simulate. So by default, it's 5 workers, but you could simulate 10 or more. So I can show you. Not going to run the code test here because it's going to work. I can show you here the load test. So you would see starting load test, and then here this is what Shiny is doing. So you get your workers, which are progressive, so until 5. Then yes, are run parallel to reflect a specific scenario for your application, and then the load test over. You see why you need Shiny. Shiny is responsible for this. Okay, so let's try it anyway. And yeah, at the end, you get a report, and this is where I want to go. That's mostly like the product report. As I said before, one minimum is the blue. So here you see a lot of blue. That's the same which was tested in the part, and that we'll experience in the session. It means people will wait in the home page, and then the wait to be over. That will be like very frustrating experience. Wait more than 20 seconds, right? So that's something to avoid. So there are multiple strategies to solve that. You could use Prometheus. You could run things in the background also, because you only have one thread, and when you are doing computation, then you block this thread, and you can do anything else. So that's another strategy you could do. So shinyValidator doesn't solve the problem, but it gives you some insight in the load test report. So yeah, here it didn't work. I'll have to figure this out, but yeah, if you work locally, then it should produce a load test report. Something going on the server side, our studio workbench, I have that problem. Okay, so about 5 minutes because we started a bit late. Just 5 minutes to talk about CI. That's the ultimate goal, to make all these things run on CI/CD. So this is an example of what you would sense on GitLab. So you would get on GitLab, you get some bubbles for your pipeline, each different step. On GitHub Action, it's slightly different. This is, I would say this is a bit complex, but anyway, there was a crash in the there was a crash in the load package restoration. Which is quite strange because I do have these system dependencies. So anyway, back to this. So if the CI/CD file, in our case, we get a folder. If you are familiar with this GitHub folder, you have workflows inside. So you can have RTMD checked, you can have package down, you can do what shinyValidator here, which is set up by the package shinyValidator. And this file here, yeah, it will run on main, on master, on pull requests. You specify the operating system you use. So you have a matrix, and then you run on 3 different operating systems, but you could have Windows, Mac. Then it will set up different things, like you have different steps, Panda, R, system which are missing, RM, install Canon, Chrome. This is actually the audit app. It's called here. So typically, if you want to have to do here is customize this part. So if you want to disable load test, you would have to explicitly do it like in this load testing equal false, profiling false, blah, blah, blah. You can add other scripts if you want. That's just a boilerplate to get you started. You're just free to build on top of that plate. And once everything is set up, you have GitHub page enabled. So for GitHub page, I have to go. You have to go your settings, you click on A. Yeah, this is automatic, so you don't need to change anything, but this is where you pick up the URL for your report. So your report will be deployed here if the pipeline succeeds, which is another problem. Yeah, but the only thing you need to do, just push, and then you need to fix the CI/CD. So in our case, there was a problem during the restoration. If you look at the code, yeah, there is actions also. So so we can inspect what happened. We have audit app and we get the test. So the load test is working. I see that's happening on your workbench. So I'll have to figure. And then the report is on GitLab page. So you need to go here, click here. We get the report with the crash test. So that's nothing because it was a boilerplate app, the Golem basics. Yeah, any reactivity, there is no input. It's not really meaningful, but I get report on that page. So what's the next step for you? And then I will end on so just production application, try to set up validation, shinyValidator on an existing Shiny app. So at Novartis, we are using it in quite complex projects, specifically 3 big projects. And so far it's working quite well, just allowed us to track bottlenecks. And I was not expecting so much from the profiling, but that's actually very helpful. So for a very complex project, I work with a colleague, and then we generate a lot of code. We can generate like 500, 1,000 lines of code per day. Then you must, that code doesn't really destroy what you did the day before. So that's for that. Yeah, and CI/CD is not easy. It's just not easy. It's super complex. Just with or without shinyValidator, it's with shinyValidator. And don't be really frightened if you see error. That's normal. Most of my time, I see errors. I get message from GitLab because my pipeline is broken. So that's perfectly normal. I would say it's also good if you can run the code locally, just test it locally before sending it to CI/CD. And I would recommend some things, the Engineering Production Shiny Apps book, which contains a lot of references for testing, particularly testing, doing load tests, and also structuring your application properly. And here, that's not really related to anything CI/CD, but yeah, my book about outstanding user interfaces with Shiny. You can order it on CRC Press, and the online version is still free, right? And get it. User interface. Yeah, and that's the book. Just basically how we have a very nice interface application. Thank you very much for your attention. Yeah, again, if you did to run now, don't be afraid. You can try it later. The workshop was recorded. You can follow me on Photodon. I don't know how to pronounce it. And yeah, thank you very much for your attention. Care, but yeah, in that case, really put the question in the issues, and I will answer. Thanks so much.
I think someone said they were going to stick around to answer questions. Sorry, I was troubleshooting while I was trying to kind of follow along. So I missed where you're able to find the report that is generated. Where is that located? I was using Workbench. I don't know if that makes a difference.
Yeah, I was also working on the report at the moment. You can find it in public. You get a public, and in that public folder, you have the main file, which is called index.html. And this file, you can left click, view in web browser, and it will open the report in the.
Okay, I see it.
This time.
Yep, thank you.
Yeah, it's got public. It could be called whatever you want, actually. So that's that will probably change in the future. More flexibility to call it whatever you want.
Yep, that's fine. I just need to know where it was. Appreciate you. Thank you. Great workshop.
Thank you. Yeah.
Hey, David, Richard has a quick question. I can't tell if it's something to do with the server, or if it's maybe something with the process here.
Yeah.
Yeah. Did you see his message here? Says he's it's a little bit up. It's by having issues still with check audit requirements, missing Chrome browser locally. It could be something on the server. I wasn't sure if you see it. It's at 11:37 a.m.
I think Richard was working locally, if I understand correctly. Yeah, maybe Chrome is not installed, or it's probably missing in the past, actually. Shiny test 2 probably can't find it. So yeah, under 2 relies on Chromot, and then I think there are some options you can specify. You can specify the path to so you go to Chromot. I had this issue also. It's over here in that page in the README. I have some articles. You can get that version. Yeah, specify this is so try to get yeah, I think Richard gets to find Chrome. I look. Yeah, find Chrome return appropriately. I don't know, maybe I'll try to sys.set underscore Chrome and point. I also on this Mac, I also have Chrome. I have Chrome and I have Chromium. It doesn't work. It works with so maybe you can try to install Chromium if you have a Mac, or even though if you don't have a Mac, and point to Chromium instead of Google Chrome. There is Chromium and there is also that's different. On Workbench, we have Chromium browser, but you can also install Chromium. So that's a lot of things to different browser to but I think it will work with Chromium. That's the one I have on all my computers, and that's the one I get the less problem. Yeah, you can ask the question. Okay, yeah, maybe. Okay. check the application. It as I using a package structure like the one you get with Golem, you can definitely use shinyValidator. If it's not using Golem, then you can use shinyValidator, but you'll have to do some some modification in the code to be able to run the functions. And here, that's really hard to give an answer because you may have very different. And that's what the reason why I choose Golem, because it's really standard. So you know that all Shiny apps will have an app_server. They will have an app_UI. If you are free to give names you want, then I don't know really what to expect from the code. So that's harder to develop a general. So tomorrow there is the workshop, the production Shiny apps by Eric. So obviously I'm going to attend. And you also have another workshop on CI/CD on Friday. There was also some workshop on CI/CD before. So I think it's cool. There is more and more CI/CD around Shiny apps, showing we are becoming more and more serious about the way we maintain our applications.